Hello guys, this is Professor Roldan again. We are now in 2.2 of explorations, which is subsets. And a good example of that in biology would be taxonomy. Which is the science of classifying all living things. Okay, and basically when we started to organize things into sets and subsets, Aristotle came up with the ladder of life. And he basically wanted to distinguish between higher and lower animals and plants. And that was about 2,000 years ago. So today, we take it much further than that. And we have our 6 kingdoms, or 6 sets. Okay? And these kingdoms are basically Animalia, Plantae, Archaea, Eurobacteria, Fungi, and Protista. And then even more specific groupings of living things are made according to shared characteristics, and these groupings from most general to most specific are you got the kingdom, phylum, class, order, family, genus, and species. Okay, so we actually use sets and subsets and classify things all the time, and that was just a quick example in biology. So let's take a look at how we're going to do this in math using the universal set A, B, C, D, E, F, and then you have the various subsets A, B, C, D, and E. Okay, so what exactly is a subset? Well, in terms of mathematics, we're going to define it as so up there you have sets A, B, C, D, and E, or subsets of U, the universal set. So let's just say set B, let's compare B and A. So set B is a subset of set A, symbolized by B is a subset of A. So it's like a sideways U, and then with a equal sign under it. Okay? If and only if all the elements of set B are also elements of set A. Okay, this definition is taken straight out of the book. You can take a look at this on page 49. All right, well, what does all that mean? Well, in similar terms, so let's take a look at this symbol again. or this idea of B being a subset of A. So this idea is very similar to the concept of B is less than or equal to A. Okay? So less than or equal to, you know that it can be equal to that amount or it could be less than that amount or smaller. Okay, it's very similar to that concept. So B is, so you can think of a subset with the equal sign as less than or equal to A. Okay, when I say it's less than, I'm referring to smaller. The set is smaller. It contains everything in that set, but it is smaller. Or equal to, meaning the same size. So it can be the same size and still be a subset by definition because it has this equal sign there. Okay, so let's take a look at some observations from our list above. So first of all, we see that A, B, C, D, and E are all subsets of the universal set U. Okay, so universal set has A through F. Set A has A, B, C. Set B only has B and C. Set C has D, E, and F. Set D has A and B. And set E has E and F in it. So those are all subsets of U. They are less than and or equal to. None of them are equal to U. They're all definitely less than U. So we can also see that what we stated before is B is a subset of A. Okay. We can also see, so B is smaller than A, and B has everything that's in A. B and C is in A. So we can also see that A is a subset of A. So how is that possible? Because there's an equal sign here. And that equal sign under the symbol there, which is tied to the subset definition, it can be equal to. Okay, it can be the same size. So if you have the same size, so like A is a subset of A, this is also true. Okay. Now you take that equal sign out of the symbol, then this will not be true. Okay, we're gonna take a look at that when we think of proper subset. We'll take a look at that in a minute. All right. So what are other subsets in this category? So we can also see that set E is a subset of C. Okay, everything in E is also found in C, and it's definitely less than or equal to. Okay. We can also see that, let's say D is not a subset of C. Okay. And how do we say not? We just draw a line through it like this. And D, because D is A and B, elements A and B, C does not have A and B. It has D, E, and F. So D would not contain anything in C. So we would say it is not a subset. Okay, now let's take a look at the proper subset concept. The proper subset concept is very similar, but you'll see by the symbol the difference. Okay, so the proper subset, okay, the definition from the textbook says set B is a proper subset of A symbolized, by this. So see the difference? There's no equal sign. Okay, so proper subset does not have an equal sign under that sideways looking U. Okay. If and only if all the elements of set A are also all the elements of set A. Okay, let's back up. All the elements of A are elements of set B, and B cannot equal A. Okay, these cannot be the same size. And the reason for that is it doesn't have that equal sign under it. Okay? So again, we take a look at the difference in the sign. It does not have that equal sign under. So B as a proper subset of A is very similar to the concept of the less than. Okay, not an equal sign, but just a less than. Okay, B is less than A. You know that it is smaller. Okay, or it contains, but it cannot equal to. It cannot be equal to A. All right. So again, this is B is less than. B is less than only, not equal to. Okay. All right. So that's just trying to say it's smaller. Okay. It has less elements, but it cannot be the same size. Okay. Actually, let me move this. Oh, Lord. Okay, let me go back. Okay. It's a little smaller, but not the same size. All right, let's take a look at some observations again. So we can go back and also say B, not only is it a subset of A, it's also a proper subset. In other words, it is less than or it's smaller than A. Okay, it does not equal to A. So if we go to our second observation from the previous example, A is not, hold on a second, a proper subset of A. Okay, because A is not less than A. A equals A. So you cannot use this symbol, but you can use the other symbol because the other symbol has the equal sign under. Okay. We can also say that E is a proper subset of C. Okay, and D again doesn't even contain the right elements, so this is definitely not a proper subset of C. Okay. All right, so those are just a few observations. We'll do some examples in a minute, but let's take a look at, let's see here. Let's take a look at the next section. All right, now so let's take a look at the number of distinct subsets. So I'm going to read from page 50 at the bottom. It says, how many distinct subsets can be made from a given set? The empty set has no elements and has exactly one subset, the empty set or itself. A set with one element has two subsets. A set with 2 elements has 4 subsets. A set with 3 elements has 8 subsets. So we see a pattern here. And let me illustrate this, just like the table on page 51. So let's see here. All right, so let's take a look at what's going on here. So we have the first subset that it mentioned, okay, the smallest subset that you can possibly have, or the smallest set that you can possibly have, is the empty set, okay? It's basically a set with nothing in it, okay? So let's say, let's back up here, put set, subsets, and the number of subsets. Okay. Now, so the empty set is a set, and the subset is itself. Okay, the empty set is a subset of every set, including itself. Okay, it's a little weird to hear, but you'll see as we go along how this works. So, how many subsets does this thing have? We can just count it. It has 1. Okay. Has 1 subset. There it is. Okay. Then let's put an element. Let's put 1 element in there. Let's say A. All right. So now we have a set with 1 element, in this case A. And so this thing has itself as a subset and the empty set. Okay, so you count them up. That's 1, 2. 2 subsets. Okay. What about if we put 2 elements in there? So this is where it's going to start to be a little bit more clear. So we have, let me break this up a little bit. So we have itself, that's a subset, because you can, remember, subsets can be equal to itself. It can be the same size. And we have, let's say if you take out 1 element, so make this thing smaller, so we can have an A in there, we can have a B in there, like this. Okay? And then we're missing 1 more set, and that is, it's in every single set, and that is the empty set. Okay, so if we count this, so here we counted 1, here we counted 1, 2, here we're gonna count 1, 2, 3, 4 subsets. Okay, 4 subsets, and I'm running out of room, so I'm gonna continue under this thing. So let's put in 3 elements in there. Okay, so again, what's a subset? It could be equal to and smaller. So we're gonna say it's gonna be equal to itself. That's the largest subset you can have, and then we can start taking out 1 element at a time. So let's take out the C. Then we can take out the B, leave the C in there. That's another smaller set or subset. And then we can actually take out the A and just have the B and the C. Okay, so those are possible subsets. And then let's go ahead and take out 2 elements at a time. So we can take out, basically just have the A in there by itself. We can have the B in there by itself as a subset, or we can have the C in there by itself. So these are commas. Okay, so we're missing 1 more set. How small can we make this? And that is taking out everything. Okay, if you're thinking about taking out elements, you have all the elements in there. That's the first one. You start taking one element out at a time. Then you start taking two elements out at a time. And now if you take out all three elements, you're going to be left with the empty set, which is an element, is a subset of every set. So now if we count them up, 1, 2, 3, 4, 5, 6, 7, and 8. So if you can see what's going on here, we have a pattern, and this pattern is coming from base 2. Okay? Base 2 raised. How many elements does the empty set have up here in the first row? It doesn't have any elements, so that's 2 to the 0. Yeah, 2 to the 0 is 1. What about A? The set that only has the element A has one element. Well, guess what? 2 to the first is actually 2. And then the third row here, we have two elements, A and B. So base 2 raised to the 2 elements, 2 raised to the second power, that's 4. Let's see if this pattern continues here. We have 3 elements in the last row, A, B, and C, so 2 to the third power is 8. So what this does is brings us to a number of elements. That's going to be 2 to the n. Okay? So we don't actually have to list all the elements and count them up just to find out how many elements or subsets a set can have. Okay? All we got to do is use the formula. All right? So, let's see here. So for example, how many distinct subsets are there in the sets S, L, E, D? Okay. So this has 4 elements. Okay. And instead of listing them all we have to do is use the formula. So 1, 2, 3, 4 elements. That means we're going to do 2 to the 4th power, which is 2 times 2 times 2 times 2, which is 4 times 4, which is 16. Okay, we don't actually have to list them all out. All right. Next question is how many, so this is subsets. So how many proper subsets? Now we're going to go back to this definition, proper subsets. Well, remember that the definition of proper, it's taking away the equal sign. It's taking away the set that is equal to itself. It's taking away the biggest set. Okay? So if we were to list these, we have to take away one set, and that is the set that is equal to itself. Okay, so if we were listing, for example, I'm just going to start this out a little bit. Listing the subsets, we would say, hey, we start with itself, and then we start taking one out, and then we take out another one, and we just keep going and going and going. We will count up 16. We physically count 16. But since it's a proper subset, it's asking for, then it's taking away the equal sign, which means we're taking away the one that's equal to itself. So all we got to do now is this formula. Just take away 1. So all we're going to do in this case is do 16 minus 1, and that's 15. So the set SLED, or SLED, it has 16 subsets. including itself. Proper subsets, take away that one, the biggest one that equals itself, and now you have just 15. All right. All right. So now we're gonna make some applications of this into some questions. We're gonna work through the textbook, starting on page 52. All right. So on page 52, we're going to start with number 6. Whoops. So page 52, number 6. All right, so number 6 says, is it true or false? Okay, so rain is a subset of the set rain, snow, sleet, and hail. Okay. So is the set is rain included in this other set? Yes, it's right here. So we can definitely, and it's definitely smaller than or less than this other set, so this is definitely true. Okay, it is a subset. And it's also a proper subset if we wanted to answer that question as well. Okay. Number 10. Elm, oak, and pine. Is it a proper subset of oak, pine, elm, and maple? So our set on the left has elm, there's elm, as oak, there's oak and pine. So all the elements of the first set are included in the second set. That means it's contained and it's less than or smaller. So this is definitely a proper subset. Okay. Let's do 14. So swimming is an element of swimming, sailing, and kayaking. So this is asking an element. Okay, notice that there are no braces over here. Okay, which is good. That means you can use the element symbol. Swimming is an element of this other set. Yes, it's right here. So this is true. Okay, number 16. The empty set is an element of 2, 4, 6, and 8. Well, notice that the elements of this set are numbers. They're not sets. And so this is referring to elements. And this guy right here is not an element. So this is false, because the empty set is not an element. Okay? Now, if it would have asked, is the empty set a subset of this other set, then we would say it is true. It is, because the empty set is a subset of any set that is listed. Okay? All right, so we're going to go to 22. 22 is the null set is equal to the empty set. And that is true, because they mean the same thing. Okay. The empty set and the null set are the same thing. Okay. How about 23? This one looks kind of weird. A little tricky. So it's saying that a set with an element of 0 is equal to the null set. Well, we just determined up here that the null set is empty to a set that's empty. That's equal to a set that's empty. So this set has a 0 in it, which means it's not empty. Okay? So this is false. So this has an element which is 0. Okay? All right. 24. So 24 is saying the empty set is a subset of the empty set. Okay, if you look back at our chart, you will see that this is true. Okay? You will see that this is true because the empty set is the smallest possible set. That means it has nothing in there. There's no elements in it. And it can be a set to itself. Okay, it's a subset to itself. All right? Empty set is a subset of every set, including itself. Okay? So this is 24, so this is true. So let me just go ahead and put, if you're not sure why, so the empty set is a subset of every set, including itself. Okay? Now, if we take away that equal sign under that symbol, then it would be asking, is the empty set a proper subset of the empty set? And we will have to say no, because proper sets cannot be that way. Yeah, so basically the empty set cannot be a proper subset of itself. It can be a regular subset, but it can be a proper subset. It cannot be the same size. All right, let's go to another page. And let's see a few more here. How about 28? Oh, wait. So in 28, we got to determine whether A equals B, or A is a subset of B, or maybe a B is a subset of A, or maybe A is a proper subset of B, or maybe B is a proper subset of A, or none applies. Okay, so that's the directions, and then we have A, and this is in set builder notation. So this is going to be X, the set of X such that all X such that X is an element of the natural numbers, and X is less than 6. B B is, actually, you know what? Let me do another different color. Okay, so the first set is basically natural numbers start at 1, and it's going to go up to, it's less than 6, so we're going to go to 5. And set B, natural numbers start with 1, and it's also going to go to 5 in this case. Okay, so these are the same exact sets. So this can be, this is the one with the equal sign under it. So first of all, A and B equal. Okay, they're the same thing, but also we can say that A is a subset with the equal sign of B, and we can reverse it, and B is also a subset of A. Okay, so everything with the equal sign is going to apply here because these two sets are equal. Okay, now the ones without the equal sign are not going to apply. Okay, in this case, so everything that has the equal sign is going to apply because they're the same set. All right, let's do 31. So the conditions is that this set is a brand of a soft drink. Oops. And B is actually a list of soft drinks. Mountain Dew. Okay. So the question is, okay, so are all the elements in B also in the elements of A? So A&W, Coke, Dr. Pepper, Mountain Dew, those are all brands of soft drinks. So, but that is a small list compared to the, if we want to say the total list of soft drinks is huge. Okay, it includes Pepsi and all kinds of other soft drinks. So that is much larger. Therefore, B is going to be a subset of A. It's less than or equal to A, and since it's smaller, we can also say it's just without the equal sign. So it's both of those. Okay. So both of those would apply in this case, and we cannot reverse it because A is much larger. The list is way bigger than just 4 brands. Okay, and it definitely do not equal each other. So that's number 31. And let's do 35. Take a look at what's going on there. List all the subsets of the sets given. Okay. So So we can treat the null set just like the empty set, okay? And basically, it's a subset of itself. So the only subset that you're going to list here would be itself. Okay? That's it. Okay, let's do 36. We're almost done here. Okay, so that's a 0 or a circle, looks like, as an element. So doesn't really matter what's in there. Could have been A, could have been X, doesn't matter. Could have been 2. The point is that there's one element in there, so we're going to list itself. Okay? And don't forget the empty set or the null set. Okay? So let's see. Whoops. Let's do 40. A set contains 9 elements. Okay. And it doesn't really matter what they are. The fact is, you know how many elements it has. Therefore, you're going to use this formula. Okay? You're going to use this formula for subsets. That includes itself. And then just subtract 1 for the proper subsets. Okay, because you're subtracting itself. So this is going to be 2 to the 9th. And this is going to be 2 to the 9th minus 1. Okay, so in your calculators, scientific or whatnot, you're going to have to type in, well, the answer is 512. But you're going to have to type in something like 2, the button 2, and then probably a caret symbol, which looks like this. And then type in 9, and then press equals or enter. Or you might have a symbol that looks like x to the y. That's basically any base, which you just typed in 2, raised to any power. So then after you type in, or you hit this button, you're going to type in the 9, and then click equals, and either case should get 512. And of course, if you subtract 1, you're going to get 511. So it kind of stink to list these out and actually count them. It'll take all day. And that's why we have shortcut formulas. All right, guys. Well, this is going to be it for 2.2. Don't forget to do your homework. All right. See you in the next video.